Yes, sir. Audible, sir.
Hello.
Yes, sir.
Am I audible? Hello.
सर आपका वॉइस इको हो रहा है
Am
सर
I
योर
audible? Am I audible?
सर यू आर ऑडिबल बट योर वॉइस इज इकोइंग सर
Okay, 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 okay. So today probably demonstrator sir is just coming. So measurement of wavelength and velocity of waves on a vibrating string. Okay, that we will do. So just wait. Measurement of wavelength and velocity of waves on a vibrating string. Okay. Where is the echo? Where is echo? Why I am not able to listen to you? Rajan Babu? Itu kayak tanpa kata mungkin kayak sebelumnya. Hello? Are you now? If I am audible, please respond.
Yes, sir.
Okay, okay. Now, still the echo is coming or it's okay now?
योर इको इज कमिंग नाउ आल्सो
Echo is coming.
Okay, just wait. Now is it okay?
Still echo, sir.
Still echo. Okay. Now, still echo is coming.
Yes, sir.
यस सर एक्चुअली आई वाज टेलिंग दैट यू आर इन हॉल
पछे की बसंतु पूरा क्लियर आपन फेसटा नाइस फेसटा देखा
फेसटा मो काटी दी छी
आपन डायरेक्ट ऑनलाइन ले देखि आपन
नहीं से कोन को बेसी निए जे थरे थरे
अच्छी आपन इसे पिला पूरा डायरेक्ट देखिबे
से ये कोन खाना मो एटा डाकी दउ छी ठीक है हेलो
जब हम अपना देखो फेसटा यूटा क्लियर करना
Yes, sir.
यस सर सर अभी सब कुछ सही है
अभी इको कैसा है
अभी सर इको थोड़ा बंद हुआ है सर आपका वॉइस क्लियर आ रहा है समझ आ रहा है सर
अभी ठीक है ना ठीक ओके
हाँ सर अभी ठीक है
तो नचबोदे
आपन ये आईडी टा है सेटा क्लिक करना এটা আপন করতে
Okay, now you see, as I have mentioned you in the chat box, today's aim of the experiment is to determine the, so you write, first I have given the title, measurement of wavelength and velocity of waves on a vibrating string. Okay. Okay. To determine the wavelength and velocity of the waves. To determine the wavelength and velocity of the wave along a vibrating string. Is it okay? Have you written the aim of the experiment?
Can I repeat again?
To determine the wavelength and velocity
स्क्रीन शेयर
Okay, now I am giving it to demonstrate.
Sir, video froze, sir.
Video and voice paused.
सर वीडियो फ्रोज.
अरे सर का नेटवर्क स्लो है आज साइड से थोड़ा.
Yes, sir. Action.
So is it visible to everybody this experiment? Hello?
Yes, sir. Visible.
So now you write the heading is measurement of wavelength and velocity of waves on a vibrating string. Then you write the aim of the experiment and the materials required. Don't write these things. Don't write these things. Only you write the heading, then the aim of the experiment, then materials required.
सर ये लैब मैनुअल
Yes, yes.
ये जो लैब मैनुअल है ये हमें कब तक मिलेगा?
So that part I don't know.
लास्ट क्लास बाद में बोला था कि 2 हफ्ते हो गए.
So now you can write, just you write these things, then I will explain. Then it will be easy for you because you write the objection table, all the things in your rough copy. In your rough copy, you write down these things. When you complete, then you tell me, I will proceed. Complete?
नो सर.
Then, okay. So then you see, so actually in this part of, in this
Not
experiment,
completed. Complete है.
you complete or not?
No sir.
Be fast because in this experiment 2 parts. So we will complete both the part today. If you will slow, then it will be impossible to complete.
Yes, done, sir.
Okay, just you see this figure, just you see. So actually in this setup, there is a string. I will show you also in big diagram. So through the camera I can show you the setup. So actually there is a string here. Both the end is fixed. Both the end of the string is fixed. So that we are having some natural frequency, when we will give some frequency through the system, that you can say it is your external frequency. So that means we can change the external frequency. Am I audible to everybody?
Yes, sir.
Yes, sir.
Okay. If you will face any problem, you can ask me. Any type of doubt, any type of problem you will face, you can ask me. So,
Sir, little bit echo is coming.
Sir, echo coming, sir.
okay. So now is it audible?
Yes, अभी भी थोड़ा सा echo है.
So, because actually there is a speaker in this setup. There is a speaker in this experiment. So that's why some echo is coming. That's why. So actually that speaker we are using for sound system. I will show you also. That's right. So actually there is a string. So both the end is fixed. One end of the string is fixed with a speaker. Other end is fixed with a stand. So when some natural frequency is there in your string, when we'll give some frequency to the system, that frequency we can say it is your external frequency. So we can change the external frequency. So at a particular time, when that external frequency, whatever we are giving, when that frequency will exactly match with the natural frequency of the string, because the natural frequency of a string, because both the end is fixed and tension remain constant and length is constant, so natural frequency of the string remain constant. So when we give some external frequency to that string, at a particular time, when that external frequency will exactly coincide with the natural frequency of the string, at that time the resonance will be produced. That means how we can know the resonance is produced? That means at that time the amplitude of the vibration will be maximum, so that we can know the resonance is produced now. So that frequency we will note down. So now in this part of the experiment, we will see different harmonics. That means in this figure, just you see in this figure, it is having two nodes, one antinode. Node is the point at which the amplitude is zero. That means both the end point will be the node point, middle will be the antinode. Okay, so here in this case, one antinode means we can say it is the first harmony. That means it is your lambda by 2. So first we will measure the length of the string. It is in the form of meter. Then in that length, lambda by 2 is produced. That means lambda by 2 is your L meter, whatever the length is. So lambda will be 2 into length of the string for the first harmonic. Similarly, for the second harmonic, I will show you also. First, I will show you the setup part. Just you see here. Just you see here. There is a string. So one end of the string is fixed with a star, another end is fixed with a speaker. This is your speaker. I told about it. So that speaker we are using now for sound purpose at a time. Because already one speaker is connected to the system. So if we will connect another speaker, then it will not work. So that's why we are using this speaker for sound purpose. That's why some echo is coming. So now the other end of the string is fixed. There is a hook. If you see, is it visible to everybody? Hello?
Yes, sir, visible.
Yes, sir.
Okay. So the other end of the string is fixed with a hook that is on the diaphragm of the speaker. This is known as the diaphragm of the speaker. So now here the standing wave will produce. So here this is known as the Hornier power amplifier. So that means, so these two ends will connected with the system. So whatever the frequency will give through the system, that will come to the Hornier power amplifier, and it will amplify that frequency and it will send to the speaker. So now, when that frequency comes to the speaker, then the diaphragm of the speaker will vibrate. That means that string is fixed with that hook, so the string will vibrate. That means that frequency will transport to the string. So some natural frequency is there, when both the frequency will exactly match, then the resonance will be produced. Okay? Clear? Is it clear or not? Hello? Hello?
Yes, sir.
Yes, sir.
Okay. So then just you see here. So now here this is the already I told you about the first harmonic. So in this part of the experiment, first we measure the length of the string and we will see for different harmonics. That means this is the first harmonic, two notes, one antinote, that will be the lambda by 2 is your length of the string, lambda will be 2 into length of the string. But for the second harmonic, just you see there are three notes, two antinote. That means two antinote means it is the second harmonic, that means it is the 2 lambda by 2. That means it is your 1 lambda. So lambda will be the length of the string. Because in that length lambda is produced. So that means lambda will be the length of the string. For the third harmonic, just you see there are 4 notes, 3 antinodes. So that means 3 lambda by 2 is that on that string. That means 3 lambda by 2 is your length of the string. Lambda will be 2 into length of the string by 2, 3. So up to fifth harmonic we have to take, and we will verify for different harmonics the velocities are remains same. Okay, so just you write down this relation in your output. Just you write down in your rough copy. When you write your fair record, these things you write in the plain side of the record. Don't write these things, don't draw this figure in ruling side of the paper. And you write this also, data table or relation between length and overlap. So you write these things. Then you write the observation table. First you complete, then we will proceed.
Sir, now we have to write the part you have selected only. Na?
What?
We have to write the selected part only, na? For the 3 points ABC.
Listen up to the this relation first you write, then after you write this objection table in your work. Understood? What? Again you tell me. Where? These things. Where?
Below.
No, these things don't write. This is only the figure part. Don't
And the
draw.
path is different.
So just you see, first you write this heading, then the aim of the experiment, then materials required, then simply you go to this. You write this. Don't write the evaluation of data. Don't write these things. Only you write these things and in your and the data table for relation between the length and wavelength. Number of nodes and antinodes are there.
Sir, the title of the
This
column.
no. Don't
Sir,
think,
टेबल
don't.
टेबल में कौन लिखा है थर्ड लाइन?
Sir, third column,
This,
sir. The
Sir,
third column.
the column, the title of the column,
The
end of
third
the that
column.
off
Hashtag
loop something.
only one student should tell me, you ask me, then yes.
aspect of loops.
Yeah, that's
सर
hashtag.
थर्ड कॉलम रे कौन लिखा है?
Which one? This one?
The third column.
That
The
hashtag
column.
of loops.
Or this one? So just you chat with me.
No,
So that
no,
I
sir,
can.
the heading of the third column.
So
The
just, okay, number of loops. So this is the number of loops. This is the number of loops. You can write the number of loops. Okay. Now you write this objection table. When you complete, then you tell me. I will do the experiment. Complete.
No, sir.
Yes, sir.
Okay. So first you complete these things, then I will proceed.
Oh, अच्छा खाली का हाँ ठीक है आगे ठीक है आओ
Now completed. Hello.
Yes, sir.
Excuse me, sir.
Okay. So
Sir.
now,
Excuse me, sir.
complete.
Sir, I was asking what we will write under the working formula.
No working formula is here because in this part of the experiment, you have to verify for different harmonics, the velocities are clearly set or it will be constant. For the second part of the experiment, there is a formula. That part I will tell you. So no working formula is here. Simply in this part of the experiment, we have to verify for different harmonics, velocity are constant according to the theory. That part we have to verify. Clear?
So, sir, after materials required, we will write directly observations table.
Yeah. After this, you write this observation table.
Okay, sir. Thank you.
Completed? Now I will close it. Now I will proceed for the experimental setup. Yes or no?
Yes.
What? Okay. So now, just you see, is it visible to everybody?
Yes, sir.
So now, just you see, so this is your speaker, this is your speaker, so this is your vernier power amplifier. Okay, so one end of the thread is fixed with the speaker, there is a hook, one end is fixed, other side of the string is fixed with that star. Is it visible or not?
Yes, sir.
Yes, sir.
So what we will do first, we will measure the length of the string. First we will measure the length of the string. Now I am measuring the length of the string and I will tell you what is the length of the string. Accordingly you will write. So you write length of the string is 120 centimeter. That means you write it is 120 centimeter or it is 1.2 meter. Everybody you write in the meter form. SI unit. It is 1.2 meter. Okay.
Now, what is the length? Please repeat.
120 centimeter, then you convert into meter, that equal to 1.2 meter. Now I will go to the program. So this is the program. So what we will do, we will give some frequency because we don't know what is the natural frequency of the string. So we will start from the first harmonic. So I will start from the first harmonic. So now suppose I go to the 15 hertz. Just you look at the string, when the amplitude will be maximum, you will write that frequency. Then I am changing the frequency. Just first one is total hit and try method because we don't know what is the natural frequency of the string. Then I will give 14. Then I will change to 13. Then I will go to the 12. It is already starting vibration, so that means I am in a right direction. So now 11 you give. Just you look at the string, that vibration is gradually increases. Then I change to 10.5 because it is already vibrating condition. 10.5. Is it visible to everybody?
Yes, sir.
Okay. Then I will change to 10. Then
maximum.
just you look at the string. Then I am changing to 9.5. I will compare the amplitude within what frequency and what frequency the amplitude is maximum. That frequency we will note down 9.5. Now it decreases. Just you see, in compared to 10, 9.5 or less amplitude. So that means we will take it is 10 hertz. So what is the frequency now? You got.
Hertz.
So you note down 10 hertz, then in this vibration, how many notes and how many antinodes are there? Yes?
2 notes.
Antinode?
1.
One antinode.
So how many lambda is it? How many lambda is there?
Then at half.
Lambda by 2. That means it is your first harmony. So lambda by 2 is your how much length? 1.2 meter. Because in that length, lambda by 2 is produced. That means lambda by 2 is your 1.2 meter. So lambda will be 2 into 1.2. That is 2.4 meter. Yes or no? So lambda value you got it. Frequency you know. Then you calculate the velocity. What is the relation between velocity and frequency? Velocity, frequency and lambda. Just you chat with me. What is the relation?
V is equal to FV lambda.
Just you. So I am not audible what you are telling. Just you chat with me so that I can see. Because that speaker is in high volume. Just you chat with me. It is not audible now. Good, good. Deep Chawla, good. Shivam, second. Subhranshu, good. Or anybody? So that means velocity is equal to frequency into lambda. So now you calculate the velocity. Now you calculate the velocity and write in that table. Okay. How much it is velocity? That means it will be 24 maybe. Yes or no? Okay. So so according to the theory, whatever the frequency was in first harmonic, for the second harmonic, the frequency will be 2 times more, according to the theory. But here we have some error. The instrument having some minor error, and air is present inside the room. That's why we may get exact 2 times, may not be. But maximum chance is there, we may get the exact 2 times. For third harmonics, it will be 3 times of the first harmonic. So now, for the second harmonic, what will be the frequency? What will be the frequency for the second harmonic? I told you it is 2 times of the first harmonic. The frequency is 20. Roughly I will change to 20. Okay. I will see. Just you look at the stream. You look at the stream. Is it in vibrating condition or not? Are you observing or not?
Yes, sir.
Yes, sir.
Okay. Suppose I will change to 20.5. Suppose. Just you look, because we have to compare. Amplitude is more or less in compared to 20 hertz.
More.
More, sir.
Okay, now I change to 21. It is more or less?
Less.
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 Okay. Okay. Now again I will go to the 20.5. Just you see. It is 20.5. Just you look at that string. It is 20.5. And now I am changing to 20. Now it is 20. Just you look at that string. Then I will ask one question. Then again I will go to the again 20.5. Now it is also more in compared to 20. But why? When I am increasing the frequency from 20 to 20.5, the amplitude increases. But when I am coming from 21 to 20.5, the amplitude decreases in compared to 20. Who can give the answer in right? What is the reason behind it? Why it is happening? Who can say? Just you write. chat with me.
Sir, can you repeat again, please?
The
Yes.
frequency. So this is so because frequency does not match with natural frequency.
Wait. Just I am decreasing the volume. Otherwise, it is not audible. Okay, now you tell me. Yes.
Sir, can you repeat, please, the question?
So already you have seen when the frequency was 20, whatever the amplitude was there, and if I change to 20.5, the amplitude increases. And when I have given the amplitude is 21, then it is less in compared to 20.5. But when I am coming from 21 to 20.5, so it is not more than the 20. So at that time, amplitude of 20 hertz is more in compared to 20.5. Why? Are you understanding my question? Who can give the answer? So do you know inertia? So when that body, that amplitude is already in maximum condition at 20 hertz, that means it is the inertia of motion. When it is 20 hertz, that amplitude already it is in maximum position. When I am changing to 20 to 20.5, so just it is continuing. But if when the amplitude is 21, so at that time the amplitude of that string is nearly zero, or you can say it is at rest condition. When I am changing to 20.5, so that amplitude it is not exactly matching with that natural frequency. That frequency 20.5 hertz is not exactly matches with the natural frequency of the string. But 20 hertz is exactly matches with the natural frequency of the string. But when I am changing to 20.5, just it is continuing. Now you understood it is due to the inertia of motion. Okay? Now you understood? Okay, just you see.
No, sir.
Okay, listen first. Listen. Suppose initially I have suppose it is 20 hertz. Just you see the 20 hertz. Just you look at the string. Now it is 25, 20.5. Just I have started. Just you see the amplitude. Just you look at the amplitude. So again I will stop it. Then I will go to the. That means that body it can rest condition. Now I will go to the 20. Again I will start. Just you see. Sorry. Oh, same thing. It is just 20. Just you see 20 hertz. Okay. So now already you have seen in 20.5. Yes or no? Now I am giving again 20.5. That body is in motion. Already it is in vibrating condition. Now just I am giving 20.5. Now it is continuing. Yes or no? So due to that reason, it is.
Yes, sir.
Now you understood? Yes or no? Okay, good. Gurman, good. Very good. So now exact frequency is 20 hertz. Then how many nodes and how many antinodes are there?
3 nodes and 2
Sir, three.
antinodes.
So how many lambda is there?
1 lambda.
1 lambda, because it it is the 2 lambda by 2. 2 antidot means it is 2 lambda by 2. That is your lambda. That means lambda is your length of the string. That is your 1.2 meter. Lambda value. Then you calculate the velocity. Understood? 2 into 1.2, that means it will be nearby 24. Then for the third harmonic, the frequency will be the 3 times of the first. Now I will give 30. Is it visible to everyone?
Yes, sir.
So how many nodes and how many antinodes? So that means 3 lambda by 2 is your 1.2 meter. Because 3 lambda by 2 is there. So 3 lambda by 2 is your 1.2 meter. Lambda will be 2 into 1.2 by 3. That means 0.8 maybe. And frequency got 30 and calculate the velocity. Understood?
Yes, sir.
Okay. Then for fourth harmonic, the frequency will be nearly 4 times of the first. Now I will give 40 suppose. Is it visible to everybody? Okay, now I will change to 39.5 suppose. Just you look at the string. Now I am changing. Just you see it is decreases. So 39 is decreases. Then 39.5. It is also less in compared to the 40. Just you see this is the 40. Again I am giving. It is 40. Now I am changing to 40.5. So which is more? 40 is more or 40.5 is more? So which is more?
This one.
Okay, you note down 40 is more. 40. How many nodes and how many antinodes? Four antinodes. Four antinodes means it is the 4 lambda by 2. That means 2 lambda. 2 lambda is 1.2 meter. Lambda will be 1.2 by 2. That means 0.6 meter. Lambda value. Then frequency you know. Calculate the velocity. So then for fifth harmonic, the frequency will be nearly 5 times of the first. Because in this part of the experiment, we have to verify. Already I told you. Is it visible? Okay. Now you note down the frequency 50 and 6 nodes, 5 antinodes. That means 5 lambda by 2 is your 1.2 meter. Lambda will be
0.48 meter.
okay, good. Then you calculate the velocity. So now you have calculated the velocity. Yes or no? Hello. So now you write the conclusion part. No calculation, nothing, no percentage of error here in this part. In the second part, you do all the things. So now you write the conclusion part. Just you write in this part of the experiment. In this part of the experiment, I found for different harmonics in this part of the experiment, I found for different harmonics, the velocities are same or constant. If you got it is constant, you write it is constant. If you get nearly same, you write the nearly same. Otherwise, you can write it with constant. Clear? Yes or no?
Yes, sir.
Gurman, any doubt?
No, sir.
Okay, good. Then we will proceed for the second part. Yes? Yes or no? Okay, just you wait. I will connect all the setup there. Then only within 1 minute we will start. Am I audible to everybody?
Yes, sir.
Okay. So now we will go for the second part. Am I audible to everybody?
Yes, sir.
So,
Is it visible to everybody? The screen is
yes, sir.
visible to everybody? Okay.
Yes,
So
sir.
now you see. So this is your first part already completed. We have completed the first part. Then you write the second part. So this is the second part. Just you write the heading speed of wave on string. And these two lines you write. Only these two lines. That means speed of waves on a vibrating string is given by V is equal to square root of T by mu, where T is tension and mu is the linear density. So this is the working formula. V is equal to T square root of T by mu. So only you write these two lines. So now in this setup, just you see, don't draw this. Oh, you write. Be fast because in this experiment we'll do lot of things. We'll plot the graph, all the things we'll do because we have to calculate the mu value. Be fast. Complete. So now just you see in this setup, already I told you about the Vernier power amplifier, the speaker. So here there is a stand, just you see. So one end of the string is fixed in the hook of the speaker, other side is passing over a pulley. At the other end of the thread, we will apply some load. We will apply some load here. That we can say it is the tension. We can say it is the tension. So now just you see the effective length, whatever the length of the string will measure. So we'll measure from this point, from the hook point, fixing point, to this point where the string is touching with the pulley. That will be the effective length. Understood? So we'll measure that length, and in this setup, in this part, what we will do, length of the string remain constant. Am I audible to everybody?
Yes, sir.
Yes.
Any problem you are facing?
No, sir.
Okay. So now, so we'll measure from this point. I will show you also when we will do the experiment. So from this point to this point, we will measure the length of the string by the meter tape in the form of meter. But in this end, what we will do, we will keep the length of the string remain constant. And any harmonic we will choose. That means in this setup, we will do in fast harmony. We will choose the fast harmony. That means always, that means lambda will be 2 into length of the string. That means lambda remain constant. Lambda remain constant. Only we will change the load, or you can say it is the tension. We can change the tension. When we will change the tension, then the natural frequency of the string will change. Okay, because you know the formula F equal to 1 by 2L square root of T by mu. So L is the length of the string, that remain constant. Mu is the linear density of the string, that means mass per unit length, that remain constant. Because for a particular string, the linear density is constant. So mu is constant, L is constant. That means frequency is directly proportional to the square root of tension. If the tension will be decreased here, the natural frequency of the string will decrease. Accordingly, we will give the external frequency so that it will match and it will coincide and the resonance will produce, and we will measure that frequency. Understood? Understood or not? Okay. Now, in this, then you write the observation table. Already I told you we have to choose the first harmonic of vibration. You write these things. Then after it, just you write length of the string. Then you draw the observation table. Here you write the length of the string. Now you draw. Then we will start the experiment. When you complete, then you tell me. I will proceed for the experiment part. Complete? Yes or no?
Yes, sir.
Sir, 2
So
minutes.
now I will close it.
2 minutes, sir. 2 minutes.
Okay, okay. Be fast. Now I am closing it. So now is it visible to everybody? Is it visible to everybody?
Yes, sir.
Okay.
Yes,
So
sir.
first we measure the length of the string. By the meter tape, we measure the length of the string. From this point, I am measuring from this point to this point. So everybody write it is the length of the string is 85 centimeter or 0.85 cm. 0.85 meter. Okay. So now just you see in this side we have applied the load. Actually this load is 50 gram. Is it visible to everybody? So similarly there are 6 loads are here, that means it is 300 gram. So 300 gram mass is the mass, 300 gram. So now you convert into tension in Newton. You calculate the tension in Newton. What will be the tension? Hello?
So can you repeat that?
So this is the 300 gram load I have applied in this hook. So in your observation table it has mentioned tension in Newton. So that means you have to convert that 300 gram, you have to convert into Newton. So now you convert it and
29.4.
tell me. So you are
29.4
doing the
Newton.
calculation by using the calculator.
2.94.
How much?
2.94.
2.94.
Okay, that you have to convert first in kg, that is 0.3 kg into 9.8. Clear? That is 2.94 Newton. So now, so the tension remain constant now. It is 2.94 Newton. The length of the string remain constant. Now we'll run the program. Now we'll run the program. So now So now I will start the program. I have given the 20 hertz. Just you look at the string. I am giving the volume with maximum, otherwise it will not work. So now you start. Just you look at the string, then I will change to 21. Is it visible to everybody or not? Okay. Okay. Then I will give to 22. Then I will give, now it is started vibrating, 22.5. Now just you see that string, already it is in vibrating condition. Then I will change to 23. Just you look at the amplitude. So now I am giving to, now I am giving 23. Just you see, 23 the 23 hertz is more than the 22.5 that amplitude. Am I right or wrong?
Yes, sir.
So now I will go to the 23.5. Now it is decreases. Just you see. So now again you go to the 23 and you compare. Now you see the amplitude. Now you see the amplitude. Now you go to the 22.5. Then what will be the exact frequency?
$22.5.
So each and everybody will note down the frequencies for 2.94 Newton. That frequency is 22.5. Now how many nodes and how many antinodes are there?
2 nodes, 1 antenna.
190 node.
That is your lambda by 2. That is your lambda by 2 is your 0.85 meter. So lambda will be 2 into 0.85. That is lambda is your 1.7. Clear? Because always you will choose the first harmony. That means always it will be two nodes, one antinode. That means lambda remain constant, 1.7 meter. Then you calculate the velocity. What is the relation between velocity, frequency and lambda? So just you chat with me. Just you chat with, already you know that relation. You calculate the velocity and v square. And you tell me what is the velocity you got, v square value you got. How much you got the v square value? Now you calculate the v square. You calculate the v square. I want that v square.
Sir,
Value.
1463.0625.
Okay, good. Now you are right. So everybody, you write 1463.06 maybe. Okay, yes. Good. Deep Chawla, good. Ankit also, very good. Okay. So now, next, you see. Next, what we will do? Now, I will decrease 50 gram from the hanger. Now it is 250 gram. That means the 0.25 into 9.8 Newton. 0.25 into 9.8. So now you do the calculation and write that tension. Then when I will decrease the tension, the natural frequency of this string will decrease. So now already I told you that formula. F is equal to 1 by 2L square root of T by mu. Already I told you that relation. So then I will decrease this frequency, external frequency I will decrease. Now I will go to the 21. Now I will start. Now it is 21. Just you see. Now I will change to 20.5 suppose. No. So you write it is 21. 21 is the exact frequency. So now you write the frequency is 21 and lambda is always it is 2 into length of the string, that is 1.7 meter, and calculate the velocity and v square. Are you doing the calculation part or not? Okay, good. Deep Chawla, Shivam also. Okay, good. Next step. Then again I will decrease another 50 gram. So now it is 200 gram. That means 0.2 into 9.8. That will be your tension. Okay, good. So next is tension is 0.2 into 9.8. Now I will decrease this frequency. Now I will go to the 20, suppose. Then I will go to the 19. Now it is 19. Okay, I will change to 18.5. No. So you write it is the 19 hertz. Frequency, exact frequency is 19. Everybody write it is 19. And you calculate the velocity and v square. Good, good, Shivam. First, Deep, second, Sibun, third, Akash, Yas, good, Ankit, good. Then next I will increase another 50 gram, that is 0.15 into 9.8 Newton. You do the calculation. 0.15 into 9.8. Okay. Then I will decrease this frequency now. Then I will go to the 18, suppose. 18. Then I will go to the 17.5. Just you look at the string. 17.5. Then I will go to the 17. Then it will be 16.5. Suppose if I 16.5, then I will go to the 16, 16 point, now 16.5 is more, then 16, yes, 16 is more than the 16.5, then 15.5, yes, 15.5, now 15 I will go, now it is decreased. So you write down, now I will give again 15.5, suppose I will see. Yeah. So now you write 15.5. Now you calculate the velocity and v square. Now Ankit is first, Sibun second, Adarsh third, then Deep fourth. Okay, okay, good. Everybody write that data. Then last observation. It is 0.1 into 9.8 because 100 gram. I have decreased the 50. So 0.1 into 9.8 Newton. Now I will decrease the frequency now. I will go to the 14. This is 14. Then 13.5. This is 13.5. Then 13. It is 13. Then 12.5. No. So 13 is the maximum. 13 is the maximum. So everybody write 13. Oh, 488. Okay. 488. Good. 488, you got 488. Okay. So then what you will do? Just you will plot a graph between tension versus V square. Then you will plot a graph between tension versus square. So when you will plot a graph, so just do you have the graph paper now?
No, sir.
So then how you, okay, just anybody having the graph paper now? Anybody having the graph paper now? Hello?
No, sir. Actually, I am.
Okay, so just in your rough copy, just you draw. Yes? Hello? Okay, am I audible now? Hello? Okay.
Yes, sir. You are audible.
Okay. Listen, so when you plot a graph, just now you draw x-axis and y-axis in your rough copy. Okay, then you write just below the x-axis, you write tension in Newton, and in y-axis you write V square in meter per second whole square. Everybody you write now.
Sir,
Yes, Shivam, what is your problem?
sir, can,
Not audible. Shivam, you tell.
sir, can you repeat?
Okay, so just in below the x-axis, have you drawn two axes, x and y coordinates in your rough copy?
Yes,
Just
sir.
you draw x and y coordinate in your rough copy. Okay, so below the x-axis, x coordinate, you write tension in Newton. Similarly in y-axis, you write V square in meter per second whole square. Okay, is it
Yes,
clear
sir.
or not?
Yes, sir.
Okay, so then when you will plot a graph, according to your data, you will choose the scale. So now in your graph paper, there are 10 small division each 1 unit. Yes or no?
Yes,
Yes,
sir.
So
sir.
now So in your x-axis, you have taken it is the tension, and the tension minimum data is 0.98 and maximum data is 2.94. So now you write the scale. You have to write the top of the graph paper, right side of the top of the graph paper. You write the scale. Just now you write in the rough copy scale heading, and you write in x-axis. Just now you write in x-axis 10 small division equal to 0.25 Newton. 0.25 Newton. That means one unit is 0.25 Newton. Each 10 small division, or you can say 1 unit. That means 1.25, 0.5, 0.75, 1, 1.25 up to the 3 Newton. Understood?
Yes, sir.
Okay. Similarly, just you see, so 10 small division you have taken, it is your 0.25. That means one small division value will be 0.25 by 10. That is 0.025. Yes or no?
Yes, sir. Yes, sir.
Okay. Suppose your lowest data is 0.98. So how you will get that point in your graph paper? So one small division value is 0.025. Suppose you want 0.98. That means 0.98 divided by 0.025. That means you will get the number of division. Yes or no for 0.98?
Yes, sir.
How many division you got it?
39.2.
39.2 means it will be the 39th division. 39th division matlab means it is 3 big unit, another 9 small division.
Yes,
Yes,
sir.
sir.
So that point will be the 0.98 value. Yes or no?
Yes, sir.
Similarly, you can locate the points in your x-axis for different tension.
Yes, sir.
Can you do it or not?
Yes, sir.
Okay. Similarly, in your y-axis, you write 10 small division, because the minimum data is how much you got it? It is the 488, and maximum data is 1463 meter per second whole square. So you choose 10 small division is 100 meter per second square whole square. 100 meter per second whole square. Understood? If 10 small division is 100, one small division value will be the 10. Suppose your lowest data is 488. That means just you do the round up, it will be 490. Are you understanding my
Yes, sir.
point or not?
Yes, sir.
So 490 means 490 divided by 10, one division value. That is 49 division. That means 4 big unit, 4 unit, another 9 division will be the 488. Yes or no?
Yes, sir.
Similarly, you can get the different v square value in your y-axis.
Yes, sir.
So then according to your data, you can mark 5 points in your graph paper.
Yes, sir.
Oh.
Okay.
So then what you do? So you choose the origin point most. Out of that 5 points, you choose the maximum number of points and you draw a straight line, and that graph will be that line will be a straight line passing through the origin. Origin point will be most. Out of that 5 points, you choose any maximum number of points and you draw a straight line. Understood?
Yes, sir.
Can you do it or not? So listen fast. So according to your data, can you mark 5 points in your graph paper?
Yes, sir.
So then what you do, origin is common, origin is must. Out of that 5 points, whatever you have marked, out of that 5 points, you choose the maximum number of points and you draw a straight line. And that line should be passing through the origin. Understood? Suppose origin point is most. Suppose out of 5 points, when I have drawn, suppose you have drawn out of that points, you have drawn 2 points and your origin, and you have drawn a straight line. Shivam, are you understanding my point?
Yes, sir.
Okay. Suppose you have drawn a straight line which is passing through 2 points and your origin. But Oleg has drawn that graph. Oleg, am I audible to you? Hello? Okay, Oleg. Now he has responded. Okay. So then he has drawn a graph. Out of that 5 points, he has taken 3 points and origin. He has drawn a graph, and that graph is a straight line passing through the origin. But Shivam have taken 2 points and Oleg have taken 3 points and that origin of that graph. But Shivam got another 3 points which is very close to that line, because he has chosen 2 points, but another 3 points is very close to that line. But Oleg have taken 3 points, but another 2 points is very far away from that line. Are you understanding my point or not?
Yes, sir.
But Shivam graph will more accurate than the Oleg's graph, because all the points, another 3 points are very close to that line, but Oleg's 2 point, that another 2 points is away from that line. Suppose if I will draw one line, that line is not passing through any points, but it is passing through the origin, but that line is not passing through any points, but all the 5 points are very close to that line, very close to that line. So that graph is more accurate than Oleg's and Shivan's graph. Are you understanding my point?
Yes.
Okay.
Yes, sir.
If all the points will pass through the line, then it is excellent. It is excellent. Are you understanding my point? That means your data is 100% right, whatever you have taken the observation. Okay. Then what you do, you choose any 2 points which is in that line, and just you draw the perpendicular to x-axis and perpendicular to y-axis from that points. That means you calculate the del x and del y. Are you understanding my point?
Yes, sir.
That means del x will be the x2 minus x1 by y2 minus y1. That will be the slope inverse. So that del x by del y will be the delta t by del v square. Yes or no? Shivam? Del x means in x axis what you have taken?
Sir, tension. Yes, sir.
Tension. If you will take the del x by del y, Deep, are you understanding my point or not? Nilesh?
Yes, sir.
Okay, good. So now you have to calculate the del t by del v square. So that you can say it is the t by v square. Yes or no?
Yes, sir.
So that t by v square you write in that graph. That value, whatever the value you will get, that value you have to mention in that graph. So that t by v square is your mu, that is the linear density of the string. Yes or no?
Yes, sir.
Okay. Then you write the calculation part. Just you write the calculation. Asutosh, are you writing or simply you are listening and sleeping?
No, sir. Writing, sir.
Okay, good. Okay, good. Ankit?
Yes, sir.
Okay. Harish?
Yes, sir.
Okay, good. Okay, good. So then you write the calculation. So linear density of given string, given thread or given string, whatever you can write, linear density of given string mu is equal to t by v square, that equal to whatever you got that value from the graph, you will write there. And in bracket, you write from graph. That means you got that value from the graph. Understood?
Yes, sir.
Sanskar, are you understand my point? Sashwat?
Yes, sir.
Yes, sir.
Okay. Then you write the standard value of mu. You write the standard value. Standard value of linear density of given string mu equal to 0.00215 kg per meter. That is the mass per unit length of the string, or you can say it is the
Can you
mu,
repeat,
linear density.
sir? Can you repeat the value?
The standard value is your heading. The linear density of given thread mu equal to 0.00215 kg per meter. Then you write the percentage of error. Then you write the percentage of error. So standard value minus observed value by standard value into 100. And you give the mod sign because the percentage of error is always positive. And you can calculate the percentage of error. You know the standard value. You have calculated the observed value, that is your t by v square. and you can calculate the percentage of error. Yes or no, Asutosh? Shashwat, any doubt up to this?
No, sir.
Okay. Then you write the
Not
conclusion.
also.
Then you write the conclusion part. So then you write the conclusion. In this part of the experiment, I found the linear density of given string mu equal to this much. Whatever you got, that value you will write. And having percentage of error is whatever you got, you have to write. Clear? Swarup Ranjan. Swarup Ranjan.
Yes, sir.
Clear or not?
Yes, sir.
Any doubt? Anybody having any doubt in this experiment? Finally, in your record, you will write your name, registration number, branch and section after the conclusion.
Okay, sir.
So anybody, any doubt, you can ask. Okay, percentage of error, Gurman Singh, you write the standard value minus observed value by standard value into 100, not in denominator 100, you multiply in numerator 100. That means standard value minus observed value in bracket into 100 by standard value. And give the mod sign, or you can write the difference. You can write the difference of standard value and the observed value into 100 by standard value. Okay, either you can write the difference or you can give the mod sign, because difference means it is always higher to lower, greater to smaller. Okay, any doubt or anybody? Something has written? Yes. Standard value is 0.00215 kg per meter. Okay, Deep, already he has done my duty. Thank you, Deep. Okay, Gurman, already he has, that means you have plotted the graph. Gurman. Can I show your graph, Gurman? Can you show me your just Gurman, you show your graph? Where is Gurman? Then how you have calculated the... Okay, that means you're a year. Okay. So because just before that group section students have plotted the graph, and so also, because I can know your graph is right or wrong. If you show me, then I can know whatever you have plotted, is it right or wrong. Because when you plot the graph, you have to plot in a sharp pencil, and it should be, you have to mention the scale, all the things in that graph, and that value, whatever you have calculated t by v square, that value also you have to mention in that graph paper. Clear? Or anybody having doubt? But just you show me, Gurman, just where is your figure? This is, but where is Gurman? I am not able to see. Kodi. Eight at the conflict. Gurman, where? Gurman. No. What? Okay, anybody having doubt in this experiment? Hello?
No, sir.
Or
No, sir.
No,
anybody
sir.
anybody having the graph paper now? Because another 5 minutes left. Anybody having the graph paper? Okay. If so, next class again we will meet each other. Okay, now you can leave.
Thank you,
Thank
sir.
you,
Thank you,
everybody.
sir. Thank you, sir.
Okay. Good.
Thank you, sir.
Now you can leave.